All right, good afternoon. Like Ralph said, my name is Leo, and I'm a backend developer on Confluence Cloud. I've been with Atlassian just over 3 years, but recently I joined the Confluence Cloud ecosystem team, which is why I'm suddenly qualified to give this talk. So, understanding JWT authentication for Atlassian Connect. What does this talk about? We're going to do two main things. We have a deep dive into everything about JWTs, and we're going to learn about how JWTs fit into Connect authentication. Just as a preface, notice I said JWT, not JOT or JWT. I think any sane realize that it can only be pronounced JWT. I mean, it's 3 consonants. Come on. All right, so first of all, I'm going to try and convince you why you should care about this topic. Then we're going to invent Connect authentication from the ground up, from first principles, you and me together, but mostly me. Then I'm going to share some tools and resources for you to take home and use. All right, so why do we care about these nitty-gritty details about authentication and how it works? Why not just do what Ralph said and use those frameworks and it'll be fine? Maybe it's the relentless pursuit of knowledge, or insatiable curiosity, or maybe you just walked into the wrong room, in which case, please stay. The real reason is to eliminate unknowns, open up that black box, and really understand what's happening in your app. We want to give you the tools and knowledge to debug any problems that occur in the area. Ultimately, it's about writing and shipping code with confidence. All right, so now we all really care about this topic. I'm going to walk you through how we're going to invent Connect Auth from the ground up instead of telling you how it works today. So our problem, how can we design a secure protocol for apps to talk to Atlassian products? Actually, pretty simple. I'll have a PR up this afternoon. So with any kind of communication, we need to pick some method of passing information. Let's randomly pick JWT. All right, it's been like 14 slides. People haven't said what JWT is. It stands for JSON Web Token, which is fairly descriptive, actually. It's an industry standard, so it's not something made by Atlassian. It's actually widely used for various things. And it's pretty much just a JSON blob with some extra bells and whistles. Every field in the blob is called a claim, and it can contain anything you like, anything that's valid JSON. Finally, an important property is that it is signed but not encrypted. So it can be verified by anyone, but anyone can also read the contents. All right, so why JWT? I mean, we had so many options to choose from. Well, first of all, it's simple. So after the talk, we'll all be able to construct and sign our very own JWTs from scratch. It's flexible. You can put anything you want in it. It's just a JSON blob. It's commonly used for things like containing a self-contained session token. And in our case, we're going to try and use it for an authentication token. Finally, it's human readable. It's just a friendly, unencrypted JSON blob. And just to prove how readable it is, I'm going to show you a real live JWT that I found in the wild. All right, if you can't read that, that's your problem, not mine. But seriously, first we need to talk about base64 encoding. Base64 encoding is a way of taking binary data and turning it into text so that it's more easily transmitted. What does that mean? If we take an example, dog will become this. I love JWT will become this. But most importantly, random binary data that could be hard to represent will still become something like this. Now, this binary data could contain things like null characters or things that could be interpreted as control codes. When we base64 encode it, it becomes a standard set of 64 characters, and it's easily transmittable with no problem. All right, an important distinction we have to make here is that decoding is not encryption. All right, repeat after me. Encoding is not encryption. Anyone can decode an encoded message, but only a cryptographic key holder can decrypt an encrypted message. So, armed with this new knowledge, you are actually getting smarter right at this moment, and soon you'll see some structure in the chaos. A JWT is actually comprised of 3 portions: the header, the payload, and the signature. If we decode that base64 data, we'll get something like this. Like I said, it's just a JSON blob. So the header defines the algorithm, which describes how the signature is generated. Then the type should always be JWT, and the payload contains literally anything. It's just a JSON blob. There are a standard set of optional fields, which we'll cover a bit later, but you can really put anything you want in there. They're all optional. Finally, we have the signature, which I'll explain shortly. So our first subproblem. We've decided to use JWTs, but how do we know that it's coming from a trusted source? First, let's talk about cryptographic hashes. So they're kind of like normal hashes, but better. So there are many properties of hashes that make them useful. They're also sometimes known as one-way functions. Given a hash, it should be very difficult to find the original input. impossible, really. For example, my hash could be to take the first letter of every word. Dog becomes D, cat becomes C, and connect also becomes C. As you can see, I cannot figure out what generates C. It could be carrot for all I know. But it's not a very good hash function because it's not collision resistant. I can easily find another word that also hashes to C, such as carrot. So what about this one? I'll increase every letter by 1, kind of like a Caesar cipher. Dog becomes EPH, cat becomes DBU, and connect becomes DPUFTU. That's definitely a collision-resistant hash. Every input hashes to a unique output, but it's not a very good hash because it's not one way. I can easily go from the output back to the input. In that sense, it's kind of more like an encoding than a hash. All right, let's look at something designed by someone far smarter than I am, HS256. You might have remembered seeing this in the algorithm header of the JWT. So, it's not just a normal hash function, it also takes in a secret key. If you hash dog with the secret key secret, you'll get something like this. Similarly, cat with the same shared secret becomes this. And connect will become something like this. Now, given that output, you cannot figure out what the input was. It's impossible. Don't trust me, trust this thing called math. Similarly, I can't find a different set of combination of input and shared secret that can generate this, the same output as any of these. It's practically impossible. So what does that mean? Well, if Alice and Bob both know some shared secret, and Alice wants to send some cat memes to Bob, which I'm sure she does fairly often, she can actually use HS256 to generate something called a signature with her shared secret, something like this. And then she can send both the original data and the signature over to Bob. Now, even if some evil hacking robot in the middle tries to swap out those nice cat memes with some phishing email, the signature will no longer be valid because the content has changed. In that sense, Bob can know a few guarantees with this. First, we can be sure that any data that we get that is signed has not been tampered with. It has not been changed. Secondly, we know that the sender is someone that's trusted. They must know the shared secret. All right, so how does that work in the context of a JWT token? Well, first, we take the basic to4 encoded version of the header and the payload, which contains all the useful information about the token. Then we apply HS256 with our shared secret. And finally, we apply a round of basic to4 encoding to make sure it's nice and sane. And that should give us the exact same signature as what was sent to us in the token. And if that matches, then it's valid. So as long as the signature is valid, a JWT token is safe. It can't be tampered with. The contents are definitely what was originally sent by the trusted sender. All right, so that's all fine and dandy, but we talked a lot about this shared secret. How do we convey the shared secret with the two parties? Well, suppose, hypothetically, we had something called an install lifecycle with our Connect authentication. And suppose there was this section called the install lifecycle, and there was some endpoint we could specify there. And suppose the product, the Atlassian product, Confluence or Jira or whatever it is, calls that install lifecycle upon install. And finally, theoretically, suppose it sends some kind of payload like this with some kind of client key and shared secret like this. Obviously, this is not all hypotheticals. We saw earlier in Ralph's presentation that this is how Connect authentication works. The client key uniquely identifies the product and tenant, and the shared secret is something that you definitely need to store for later. So when you're writing your app, make sure you always store that shared secret. Each tenant that you install on will have a different one to remember. All right, so that's good. But how do we know which shared secret to use to verify an incoming request or generating a request? We need to know the tenant that sent the information. Our app can be sold on many different tenants. Each one has a different unique client key and a different associated shared secret. So it's easy. We put that information into the JSON payload of our JWT token. We'll use the standard issuer claim, ISS, which is defined in the JWT spec, and we'll use that to put in the person that it came from. In this case, it should contain the client key of the product, or, for example, your application's unique app key. Once we have the information, we can now retrieve the shared secret and use that to verify the signature or generate our own. Sorry, that was easy. Yeah. How do you prevent token reuse? What do I mean by that? Suppose our token falls into the wrong hands, that nefarious, evil hacking robot again. This token contains everything we need to authenticate and act on our behalf. So how do we limit the blast radius of that situation happening? Well, we can use the standard issued at and expiry claims to make sure that that token doesn't last forever. Even if it gets captured by someone else, it can only last a certain time. So these values are actually seconds since epoch, a Unix timestamp, where epoch is 1st of January 1970. All right, that was easy too. Our final subproblem. How do we preserve the integrity of the request? So what do we mean by integrity? So when we make a request, we have all this information, the endpoint we're talking to, the request parameters, maybe the post payload. How do we make sure that that data comes from us to the product, or vice versa, all the way through those internet pipes without being tampered with? An evil hacking robot shouldn't be able to modify anything, including the endpoint or the request parameters. You may have seen a theme by now. We just put everything into that JWT token. So the solution is we encode all of our request information into the JWT token. We split up the request into its constituent parts. We first take the HTTP verb, in this case, the GET. We add an ampersand. Then we take the canonical URL, in this case, REST API content. And then we take each of the query parameters or paste payloads in alphabetical order and add each of those as well. So this gives us a kind of consistent way to represent a request. Then we take that whole string together and we apply something called SHA-256 to it. So this is another hashing function. It's a close cousin to HS-256, but it doesn't use a shared secret. It just uses the input itself. And then we get something like this. Then we can take this string and put it into our JSON payload as the QSH claim, or query string hash. A quick note, this is the first non-standard field we've used, the first non-standard claim. This is something that Atlassian does. Maybe someone else does as well, I'm not sure. And that's it. That is our entire JWT token that we can use to prove that it came from a trusted sender, that it hasn't been tampered with, that it will expire, and that the request has come through with integrity. Somehow, we have invented exactly how Atlassian Connect works today. Wow, what a surprise. All right, a quick recap and summary of how it all works. So, from start to end, how do we verify a request from the product? First, during the install lifecycle, we store the shared secret for that client key. Then, when we receive a request, we check the expiry on the token to make sure it hasn't expired yet. Then we check the QSH claim and make sure that it matches all the request parameters. Finally, we use the issuer information in the JWT token to retrieve the shared secret and generate another signature and verify it against what we received. Now remember, all of these properties, all of the safety, it only works if you verify the token. So if there's one thing you take away from this talk, always verify your token. Nothing is safe if you don't. All right, what about sending a request to the product? Again, during the install lifecycle, you can store a shared secret with the client key. Then, when you want to generate a request, you set the issuer to your application's unique app key. Finally, you set the expiry to a short time in the future, and then you generate a query string hash based on the request parameters. Then you use the shared secret to generate a signature, and there you have it. You send the complete JWT token to the product. Now, we know now how to do the whole thing from scratch, from basics, but we don't necessarily want to do that in our application. Here are some tools and resources you can use to automatically generate and verify your JWT tokens. These JWT libraries will help you generate and verify those tokens. So there are many libraries for different languages. Here's a short list of them. Many of them are Atlassian maintained. And you can see a full list of this with all the URLs at the following developer.atlassian.com blog post called Understanding JWT. I promise I didn't just copy the entire thing for this talk. There's also something called the JWT decoder. It's a little bit misleadingly named because it's actually more useful for generating query string hashes and helping you verify them. Finally, there is something called JWT.io, which is a fantastic website that lets you paste in any kind of JWT token in its base64 encoded form, and it'll format it nicely, decode it, and show you the contents. That's all from me, so thank you for listening. Thank you for listening.
Okay. Never know which side is on and which side's off. We actually have about 4 minutes to take some questions. Anybody have any questions? Got one over here.
Hi, thanks for the talk. I have a question regarding the initial bootstrapping. So you said that the secret key is being transmitted during the install lifecycle. How do we know that this call of the install callback actually comes from an actual instance, and couldn't maybe an attacker just go ahead and acquire a number of instance URLs and then register fake keys for them so as to prevent those instances from ever installing my app?
That's a good question. I think at some point you have to trust something. And in this case, we have to trust that the initial request that comes through with the install lifecycle is from a valid source. Someone could kind of maintain an illusion for everything. Yes, Ira.
Yeah, so I've been personally asked that question about 500 times in the last 5 years. So what you can do is that you can hit basically any REST API in the product with the shared secret. So you generate the JWT token like we did in the presentation. You hit any REST API, and if you get 200 OK back, you know that it was that's the shared secret known by the instance. And the second thing you have to do, kind of related to that, is that you have to only talk with valid Atlassian cloud instances. So if somebody tries to send you in the installation payload like a URL that doesn't point to Atlassian.net or Jira.com for some really old instances, you should just reject those, because those could be fake.